All right, let's get started right away. We're going to be using our instantaneous slope formula to answer some questions. So let's look at our graph, which is actually the same graph that we had before. This is the graph of y equals x squared. And I'm going to ask us to figure out 3 different questions. So let me get a nice bright color here. My first question is going to be, we need to find what the instantaneous slope is at the point x equals 2. And that's because we actually posed that as a question in the last video, and we never actually answered it. So what is the slope at x equals 2? Next, maybe we'll do this in a different color here. Get some green. I want us to figure out what the instantaneous slope is at any point A. So it's all fine and good to find it at x equals 2, but let's see if we can figure out a more generic formula for finding the instantaneous slope at the point A. So first at 2, then we're going to try to generalize it to A, and then last but not least, we need to use the information in B to figure out when, or at what point, or maybe I should say where on the graph is there an instantaneous slope that's equal to, let's say, -6. So those are our 3 questions. It's bothering me that this doesn't have a question mark. Oh wait, neither did the other one. We'll do green, and then we'll go back to our purple color, and then we'll solve that first question. Okay, so starting with instantaneous slope, let's come here to our blank screen. We know that we can find instantaneous slope using limits, specifically the formula that says let's find the limit as h goes to 0 of f of a plus h minus f of a all over h. And remember, we're not just pulling this formula out of thin air. We actually created that formula looking at the coordinates for 2 points that are very, very close to each other. And we want to find the answer, at which we're going to plug in some numbers in order to do that, as h, the distance between those points, gets closer and closer to 0. So in this particular situation, A is going to be the point that we're starting with, right? Because this is like y2 minus y1 over x2 minus x1. And the reason that we don't have anything else here is because they canceled. If you remember, we had a minus a. So y1 in our question here is the point right here, the point 2, 4. So we know that our a, f of a, that we're talking about in our, that's how we label it in our formula, is actually the point 2, 4 on the graph. So let's see if we can fill that information in. We are looking to find, remember f of x here is x squared. We're going to say, let's find the limit then, as h goes to 0, of f of a plus h. That's basically going to be, a is 2, right? Because that's basically x. Why don't we just write in there? F of 2 plus h and f of 2. So f is, our function is x squared, so we're going to say 2 plus h squared, because our function is take the stuff and square it, minus, just take 2 and square it. So that's minus 2 squared, which is going to just be 4, right? So 2 plus h squared minus 2 squared all over h, which we can't change because h is what we're trying to make go to 0, making the distance between those points go to 0. So we're going to do this all out. Again, limit as h goes to 0. 2 plus h squared, that's basically, we're going to need to factor that. That's going to be 2 plus h times 2 plus h, which if hopefully you're getting good at doing those quickly in your head. That factors out to 4 plus 4h plus h squared minus, so that's what this factors to, or yeah, FOILs out to, minus 4 all over h. All right, we still have a problem because in order to find the limit as h goes to 0, we have to plug this in. But if I plug in 0 right now, I'm going to have an error. I'm going to have a problem. So we need to see if we can simplify this. And right off the bat, I can see something that I can simplify. I'm going to use a different color because I'm worried that the simplifying is going to get lost here. So I can see 4 minus 4. Those cancel each other out. Then I can also see that I now have 4h plus h squared all over h. Well, that means I can actually cancel an h out of everything, right? If I have 4h plus h squared divided by h, I can just cancel an h here and I can cancel an h there. So what I'm going to end up with is the limit as h goes to 0 of 4 plus h and nothing in the denominator because we just canceled it, right? So what's the limit as h goes to 0 of 4 plus h? We can just plug it in, right? Plug in 0, and the answer is just 4. So what does that mean? Well, what it means is, going back to our question here, what's the instantaneous slope at x equals 2? Well, we used our formula. We plugged in the values. We found 2. We started at 2. And then we did all of the problem out. And the answer we got was 4. So what's the instantaneous slope? The instantaneous slope is 4. So right here, the slope, the rate of change is, there we go. All right, that's the answer to number 1. Okay, next, we're going to answer this in a more generic way, going back to our screen here. We're going to do all of this the same, except instead of trying to find the answer at 2, we're going to actually try to find it at a. And we're going to try to create an equation just using a. So let's clear this and try that over again. So we want to find the limit as the distance between the 2 points is going to 0, but we're going to actually keep using a instead of trying to replace it with a number this time. Let's do it generically. In order to rewrite this, because when it just says f of something, it doesn't really mean a lot because we need to know what the function is. Remember, the function is x squared, right? We're doing y equals x squared. That's what we're finding the slope of. So let's plug a plus h and a into that function. So that would be the limit as h goes to 0 of a plus h squared minus just a squared. And let's simplify that just like we did before. FOIL it out or distribute, however you want to look at it. And that's going to end up being a plus h times a plus h, just like we did it before with the 2. Except that's going to give us a squared. This should say limit as h goes to 0. A squared plus 2ah plus h squared minus a squared. Whew, barely fit that in. All over h. In order to find the limit as h goes to 0, though, I need to do some canceling because right now I have a little bit of a problem. I'm going to end up with 0 in the denominator. But we can do some easy canceling, same way that we did last time. I have an a squared minus an a squared. Thank goodness I can cancel that because I barely fit it on the side of the screen. So a squared minus a squared, they go away. And if this seems redundant, that's okay. It's very similar math. There's an h in the denominator and there's an h in each term. So I can cancel one from each. This h goes away, this h goes away, and I end up with just the limit as h approaches 0 of 2a plus h. So if h is going to 0, I can finish this now. Plug in 0, and the answer is just 2a. So for any point on the graph of y equals x squared, any point on y equals x squared, if I want to find the instantaneous slope, I can just plug it into this formula, 2 times a. That's the formula. If I want to know, and I could say equals slope. 2a equals the slope for any number a. Now that is going to make it really, really easy to solve letter C, which actually I might even be able to solve right here. Let's see if we can do it. What we're saying is that if I want to know a slope, I just have to figure out what I would need to plug in for a to get the number. So I'm saying, when is the slope equal to -6? Well, when is 2a equal to -6? That's another way of rewriting that. When does 2a equal a slope of -6? Well, I don't even have to do this out with much algebra. I could divide both sides by 2, but I know that a would have to equal -3. So what does that mean? Well, it means that on the graph, which is now kind of hidden under all of this, which is -3, which is kind of off the charts up here somewhere if you see it on the graph. That has a slope. If I were to try to find the instantaneous slope at that point, it would be -6. Pretty crazy, right? If that made your head hurt a little bit because it was a lot of information, that's to be expected. You're learning something that's totally new that you've never done before. I would recommend rewatching portions of this if you think that it might help you internalize the information. We will absolutely be practicing this in class with a whole bunch of different functions, not just y equals x squared. But hopefully this gave you a little bit of a taste of what it means to go to a point at infinitesimally small, I always want to mess up that word, at that exact point, we can find what the rate of change is using limits. And we really wouldn't be able to do it otherwise. We wouldn't legally be able to do the math that we need without the foundation of limits. All right, there's still a lot more to do, but that's the end of your video lesson, and we'll pick up with the rest of it in class.